I know what you're saying. You're saying, Dean, I know hard disks. I understand them. I don't need, and anyway, I don't care because I'm looking at the image. Suppose the hard disk is corrupt. Suppose you need to understand that this set of hard disks needs to be pulled out of this housing and put into another housing. You need to know why it's failing, and then if it's worth it within this investigation for you to actually pull the platters at the manufacturer. Think about that. You have to decide. I mean, it could be a $100 million case that you're working on. It could be a class action suit that hinges on one hard drive, and you have to understand everything there is about that hard drive. So therefore, we need to break down the hard drive and take a look at it. And that's what we're going to do. We're going to tear apart the hard drive and take a peek inside and understand it. And then once we do that, we're going to relate that to that physical structure to a logical structure, and we're going to talk about all hard drives and file systems that go on them. The file system has to understand where the physical drive portions are. It needs to know how to interact. The computer, before there is an operating system, needs to know where to get the operating system from. Once it gets the operating system needs to logically lay out the file systems to be able to access the files that it has for its own running and for the user space where those files are going to be sitting that the user is going to demand. How to write and read those particular files on a regular basis. So since the computer needs to know that, you need to know that, and that's what we're going to talk about is hard drives, disk interfaces, the boot process for the major operating systems that we care about. We'll also talk about CD-ROMs and DVD file systems, dip our toe into RAID, and then this is the first time that we actually talk about a tool. You'll notice that we haven't been discussing tools up to this point. We have to get the theory down and understand what's going on before we can reach out and grab a hold of a tool. I'm sorry that it takes so long to get there, but we need that basis of information. Okay. Do you understand what a platter, track, cluster, cylinder, sector, head is, and how reading and writing is achieved? If you don't, this is a great way to learn. If you do, you may have taken an A+ course. So let's talk about the hard disk altogether. It's a collection of platters. Those platters that sit inside of there are has a mechanism to read and write. And the disk drive rotates at a very high speed. Standard disk drive speeds today for rotational speeds are 5,400 and 7,200 RPMs. For you, when you are creating your forensics workstation and you're creating your disk drive sets, I think that you should think about RAID as a tool. I also think that you should purchase hard drives that spin at 10,000 RPMs. There are faster drives out there in certain arrays, 15,000 and 17.5 thousand spindle speed drives. 10,000 is about affordable for most of us that are out there. You can buy a Western Digital Velociraptor 1 terabyte drive today, somewhere around $150 to $200 depending on how you purchase them. And remember, how many systems are you going to encounter these days with a terabyte of data on them? So you need to not have 1 terabyte, you need to have 2 or 3 terabytes on hand. There are plenty of disk drives that go above 1 terabyte, but we want to pick drives that are stable, fast, efficient, and are not prone to error. And the larger drives at this point are a little prone to error. As our disk capacity goes up even further, it may be that we can choose those 2 or 3 terabyte drives that are out there, but that's usually for end user purposes and not for lab forensics purposes. So we've got this hard disk in front of us. It's made up of platters. The platter is a circular disk where the data is stored, and the data is often on both sides of the platter. That platter has tracks in it, which are concentric circles, and each particles on a single platter. So this is one circle. So you can see right here that it is each one of these rotating tracks right here, that gray area is one track on the hard drive. A cylinder is a collection of all tracks. Think in 3 dimensions here. So we've got one track here on this side. On the bottom side, we've got another track. For the next platter down, we have a pair, and for the next platter down, we have a pair. And however many platters you have, that's one cylinder treated as a collection of tracks. A sector is one piece. It is a partition of the track data. It sits right up here at the top here. That's one sector. Depending on how the drive is hard formatted before we actually get to it, typically it's 512 bytes of true data. Now we're going to look at that in a little more depth in a minute. A cluster is a group of sectors. This is the basic storage unit that the operating system understands. So a cylinder is a collection of all the tracks from the same platter that are the same radius. A sector is a partition, and a cluster is a group of sectors. The head is the tip of the read-write arm. There is a head on each side. It does the reading and writing function. It is the tip of the actuator arm, and that slides back and forth among the different tracks to pick up the data that is sitting in clusters and sectors. When we write data, we are aligning the particles in the magnetic media on that particular platter. Now what you're looking at here is an electron microscope showing you the ones and zeros on the drive. This is very, very small. If you ever crack open a hard drive and you look at the read and write, let's go back here for a second. If you look at the head, you almost can't see the tip. It almost looks like a needle, but it's even smaller than that. If we were to take the spinning hard drive and we were to extend it to the size of a wheel on a car, the accuracy and the precision of the head and the actuator arm would be so precise at this point that we would be able to drive about 150 miles per hour and stop at any point within 1 foot. Think about that. Going 150 miles an hour and being able to instantaneously stop within 1 foot of your chosen destination. That's how accurate this device is. It's writing and reading, changing the magnetic portion of this disk as it flies around. Now, a lot of people will talk to you about calculating disk capacity. Do not do that anymore. It's a combination of clusters, heads, and sectors together, and they create this calculation. And you'll see a lot of quiz questions out there for the exam that ask you to calculate this. No. Because it's a myth. It doesn't work like that. First off, you don't truly format the hard drive anymore. It comes pre-formatted from the individual manufacturing facility. It is all set up for you, and that physical hardware is virtualized just a little tiny bit. When you actually reformat a hard drive, you are not truly reformatting that hard drive at the ones and zeros level. You are doing a lot less than that. You're actually clearing the media. Okay, so don't do the disk capacity calculation because of LBA and solid-state drives. Now, solid-state drives you probably know, but what is LBA? Well, it's logical block addressing. What happened was engineers a long time ago said, you know, hard drives aren't really going to get that big. Now, let's think about it. I know that you've heard the quote that Bill Gates said, 640K is all the memory that you'll ever need. Well, engineers said 504 megabytes is the largest size of a disk drive that you'll ever have to worry about. The problem is that this hard drive space is not fixed, and it has grown over time to now we have 3 and 4 terabytes of drive space in a particular machine, And the BIOS that is there is not smart enough to understand it, so we have to do this BIOS hack to get around this limitation of 504 megabytes. So instead of addressing things like cylinders, sectors, heads, only one value is used for each sector number. And it's kind of like a telephone number with a country code, area code, and then a local phone number. And that's how the large block addressing is set up. You don't need to know how to do the calculations on large block addressing because it's all done by the manufacturer and abstracted from us, and we don't care about it. You do need to know how much slack space is in each place, but that's going to be a little bit easier to figure out. The reason why this works is because it leaves the geometry translation to the drive itself, which is not limited to the 504 megabytes, instead of allowing the BIOS or the bus to actually do this activity. So the components of a hard drive, a hard disk, are what we're going to cover next. We're going to talk about sectors, bad clusters, sectors, bad sectors, clusters organization, the size, slack space, and lost clusters. And we'll cover that next.